What is Newton-Raphson method? So there are two conditions. If a function is continuous and differentiable, function must be continuous and function must be differentiable. Okay? Any function written as fx that is continuous and that is differentiable. So continuous means what? Okay, continuously take the shape. What is non-continuous function? It takes the shape like this way, and then there is no value in here, and then just start from there. Okay, so there is no connection. So more specifically, it is said if x minus y less than very small number, then fx and fy, difference of them is also very small. Sorry, it is delta. Let me write more specifically. X minus y, if their distance is very small, less than small, then suppose here is x and here is y. Here is y. This is x, this is y. So their distance is very small. Okay? So that is x minus y equal to very small distance. Then fx and fxy distance is also very small. On the other hand, if I took here, suppose this is equal to 4. Okay? And that is equal to what? 4 suppose 1. So 4 minus 4.1, that difference is very small. Okay? Less than 0.2, right? But this difference, this is f of 4, which is equal to, in here, suppose this is equal to 10, and then that is f of 4.1, which is equal to 20. So that difference is not small, right? So that means 20 minus 10 is not very small, right? So you understand what is a function is said to be continuous. If you ask me to say these things in more simple way, little change in x, only little change in y-axis. Little change in x-axis, very little change in y-axis. A function is said to be continuous if left-hand limit, suppose left-hand limit, it is written as L, left-hand limit of the function and functional value, and right-hand limit are the same, then the function fx is said to be continuous. When a function is said to be continuous, that is the criteria. So there is also a function is said to be differentiable. One of the conditions that a function is differentiable, it must be continuous. Okay? So then, if a function is continuous and differentiable, then any function, suppose I have written x cubed minus 7x plus 100 equal to 0. So what is the value of x that satisfies this equation? Another person wrote, this is my function x to the power 10 minus 5 x to the power 4 plus 2x equal to 2x plus 5 equal to 0. So what is the solution for the x? Are you understanding? Are you understanding? I have a function. These functions are continuous and differentiable, but what is the solution for the x for this function? 400 years ago, Newtons and Raphsons, they gave a solution. Very interesting, very simple solutions, and you will like it. Because of what? These Newton-Raphson method are going to be used for the rest of the all of the derivations, like negative binomial regression, and then Cox regressions, linear mixed effect model, all of those things, we need these things. Okay, let me write these things formally. And from there, after that, I will finish the derivations. I have 1 hour, 15 minutes. Okay, so to find Newton-Raphson method, to find the root of a function, the root of a continuous and differentiable function, continuous and, can you see it from the back? Continuous and differentiable function. Differential function fx at point x equal to x0. The Newton-Raphson methods tells us that a better approximation approximations for the root is x1 x0 minus f of x0 so suppose I want to tell that fx equal to x cube 7x square plus 10 equal to 0. So I have to start a initial guess. Initial guess. Suppose x equal to 5. Then x equal to 5, I call the initial guess x equal to 0. So I plug that value is in there in the numerator, and I have to find the differentiation of this. If I find the differentiation of this, I have this 14x equal to 0. So now x equal to 5, I want to plug in there. X equal to flag, I want to plug in there. This is my numerator. This is my denominator. So this is numerator. This is denominator. And this is the value. This is one first approximation, first iteration. Understand? First iteration. Then second one is what? Second one, what I had, I just want to plug the first one. Again, go there, x1, and then x1, like this. In this way, it will continue up until two successive approximations give us the almost approximate result. Okay? Clear? This is what he said. Any function, if you have, they have provided this solution. How? How did they come up with these solutions? This has a lot and lot and lot and lot application. You cannot believe. Only limitation is that. Only limitations of this method is initial gas. Suppose initial gas you started with the 5 billion or 5 trillion or 5 million, understand? For a simple equations, then you might end up with a very bad result. Otherwise, it will give a stable and convergence result, approximately. Understand, right? Initial gas should not be bad. Like you have to use your intellect and conscience, like what should be the initial gas. So for example, this is a simple equation. If you put here 3 billion or 5 billion, then right, or a negative number, something like that, or something very close to zero. But how these come into an existence? They have written these things. If they did not like write these things by waking up in one morning, okay? If you come and write there, why should I believe you? What's the rationale? What's the rationale, right? You are writing something, why should I believe that? That should be the questions. That should be the question to ask. If this question is asked, then I have the answer with the derivation of this. Take a look at this one. I want to write a figure in there. That figure look like this, okay? And this is the equation of a tangent. This is called the tangent equation. Or more specifically, this is called the slope that I discussed already previously, okay? So this could be slope. I can go this fast rate, that slow rate, or I can go that faster, right? Slope, tangent, okay? So that is called the slope. And it has been written, slope means always derivative, right? Okay, so that is the place. And this is one point, and that is another point. This is called the xn, and that is called the xn plus 1. So this is the point, geometric point in here. In this case, if geometric point has been taken, it should be xn and fxn. This is the coordinate, geometric coordinate in here. And this is the slope. This is the 2 point. So equation of a tangent is what? Equation of a tangent. Equation of a tangent is written y equal to this is the equation of a tangent. These are the things was defined 2300 years ago by Euclid. He was the father of all geometry, okay? This is the equation of a tangent, slope, like this equation, this is defined like that way. So in these equations, put y equal to 0. In this case, y equal to what? In this case, y equal to what? 0, right? In this case, y equal to 0. If that is the case, y equal to 0, if I put, then x equal to what? X and plus 1. In this case, I have 0 and that. In this case, I have 0 and that. So in this case, x equal to what? X and in this case, and this is y equal to 0, right? So I want to put these things in there. So I put there 0, f prime, x and and x equal to, I put x n plus 1 minus xn plus f of xn. Okay, f of xn. So from there, I can easily write, doing some mathematical manipulations, x plus n equal to xn minus f of xn divided by f of xn. This is what we can write. This is the derivation. Newton-Raphson method. Now I am ready to start deriving Poisson regression model. Okay. Very simple, right? 400 years ago, the Newton who thought about the apple. Okay. So let me give you one real life example. Fx equal to x square minus 4x minus 7 equal to 0. We want to differentiate this and end up with twice x minus 4. Now start with x0 equal to 5. Then x1 equal to what? X0 minus f of x0 divided by f prime x0. What I got? 5 minus, if I plug it in there, 25, 20, 5. Here is negative 2 divided by, here is 10 minus 4 equal to 6. Then we have what? 32 over 6, which is equal to 5.333. Now, if you do these things x2, you will get 5.31. If you will do it x3, you will get 5.31662. And then finally x4, if you find 5.31662, something like this. Clear, right? There are a lot of applications for this one. Yeah.
Why are you starting with 5?
I just initial guess. If you do start here with the 5 billion, so that means you are destroying everything maybe. Initial guess, you will have to start. Initial guess.
But if you take 4, 3, 2, something.
Yeah. Yeah. It will change, no, but it will come and stable in there. If you come and it will stable in there, 6, 7, 10, take at a home. Okay.